There are smart lights in Bozeman and a whole lot of dumb ones. When you drive up to a dumb light at 3 in the morning and it's red and you're tired, it stays red. And it stays red. And it stays red. What do?
Run it.
You wait because you're a law-abiding citizen. And you wish to goodness that it was a smart light. Because a smart light, you drive up at 3 in the morning, it knows you're there, it knows you're tired, and pow, it's green. And if you drive up onto a smart light and you look down at the pavement, you see that they have cut a rectangle into the pavement. They put something down there and they patched it up. What did they put down in the pavement there before they patched it up? Any ideas? What? It's just a wire. That's all it is. It's just a wire coil. And when you drive your car over that wire coil, you change the number of field lines that go through the coil. Now it turns out, let's say this is the wire coil. We would have a bigger one at a real stoplight, okay? Without a car, there's field lines going through that loop due to the Earth's magnetic field, which points towards Canada and down 70 degrees. But only a couple of field lines are going to go down through that. It's a weak field. But when you drive your Toyota over that, what you're driving is a Toyota magnet. That Toyota has an iron engine. The iron of the engine has a net magnetic field that's lined up with the Earth's magnetic field, Canada and down. And so that means by driving your Toyota over that loop, you're changing the number of field lines down through the loop from 3 field lines to 53 field lines. Fight that change. Fight that change. What way does a current, induced current, flow in that loop? Clockwise or counterclockwise? Clockwise or counterclockwise? Okay. While you're voting, at University of Washington, they have a really nice parking garage that's right underneath the central part of campus. And the only people that can park there are faculty that commute and very, very rich students with very fancy cars. The rest of the students have to park in a lot that is down a huge hill. There's the lot with steps going down. Now, when you come in to that lot, there's a smart light set up that senses your car, opens a gate, and lets you go in. But to get out, there's no such smart light. There's a place where you can put 4 quarters, and it will open up and let you out. So if you come all the way down this mountain, and you don't have 4 quarters, you get to hike back up and get 4 quarters. Well, I went down at 4 in the morning with a sledgehammer. I just wanted to see whether it would work. And I snuck over there where the smart light loop was. I set my sledgehammer there and it went right up. Well, the next day I was talking about Lenz's law. That's why I'd gone down there. And I told my students that that happened. Oh. Yeah, my wife told me not to, but I did. They came back with a very interesting story. They said that they were able to take the metal can lid from a trash can, the iron trash can, and use it as a frisbee. Instead of going out the out, they went out the in. They would open their door, fling this frisbee. As it went across the loop, it would open up the gate, and they were out. Okay. Now,
It's a law-abiding citizen you are, Greg.
I didn't do it. I was just telling them physics. My wife told me I'd still go to hell, so I probably will. The answer is counterclockwise. Now, Think of it this way. I go from 3 field lines down to 53 down. I fight that change by sending induced field lines up. If the induced field lines are going up, the induced current has to go counterclockwise to do that. Counterclockwise. Okay?